Assalamualaikum and hi everyone. My name is Nur Sabina binti Rosnan. My metric number is AE210037. Okay, for this topic, I'm gonna present you about the introduction for this project. Okay, uh, the project background for this project is about the electricity that is got supplied using the sources that is burning fuel. Okay, the electricity is the most important element uh, in supplying the power to the industrial and the residential for the uses such as lighting, heating, cooling, refrigeration, machinery, and electronics. It fulfills the requirement of electricity needed. The energy sources are mostly getting from the burning fuel that is getting from the fuel that is petroleum liquid. This petroleum has high in energy density and easy to transportability. Okay, thus we can assume that the amount of consumption day by day might be increasing in that is parallel with the increasing of peoples and factories. In this report, we will analyze the data on the amount of energy that was produced by the petroleum from 2040 to 2080. Okay, this analysis will use the numerical method of and that is that is Lagrange interpolation and Newton divided difference interpolation. The collected data is taken from the official website of EIA, that is Energy Information Administration. Okay, for the problem statement, we got the data year from 2040 to 2080. That also we got the petroleum liquid generation, that is 10696 at the 2040 year, and for the 2050 the amount is 9069, and for the next is 8567, and it keep increasing in the next year, that is 2080, and the amount is 10108. Okay, based on the data set in the Electric Power Annual Tools by the US Energy Information Administration, that is also we can call it EIA, it is observed the generation of petroleum liquid, and one data is missing, that is in 2070. Okay, thus the problem statement in this project is to find the approximate value of the petroleum liquid generation in 2070 by using the Lagrange interpolation. Okay, Newton divider difference method. Okay, for this method, we were using the Maple software to prove the correctness or exactness of the manual calculation result.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Naraziza binti Sukardi with metric number AE210018. Now I will present the methodology for our project. Methodology is where the method and formula used to solve the problem and analysis are discussed in detail. There are two ways of solution that will be used in the solving process, which are first manual calculations and second simulation proving. But before that, the idea to solve the problem statement in this project is to empty the exact data of the petroleum liquids generation in 2017. So for manual calculation, we use two methods, which is the first one is Lagrange interpolation method. So in Lagrange interpolation method, we also use the linear approximation, quadratic approximation, and cubic approximation by using the formula shown in the slides. The second method that we use in the manual calculation in order to find the missing value of petroleum liquids generation in 2017 is by using Newton's divided difference method. First step is we need to draw the Newton's divided difference table, and then we need to follow the first, second, third, fourth, and the last step formula as shown in the slide to get the data in the table, and then we can obtain the value of the petroleum liquids generation in 2017. Lastly, the two methods used in the manual calculation will be proven by using Maple software simulation. Maple software simulation is one of the methods for solving the problem to verify the answer that we got from the manual calculation. Maple software is capable of solving mathematical problems, including numerical analysis. Thus, by using coding in Maple software, the answer from manual calculation can be cross-checked to prevent any mistake due to miscalculation during the manual solving process.
Assalamualaikum, my name is Najihatul Izzati. I will present manual calculation to find missing data of petroleum liquid generation for 2017. Our group chose two methods which are Lagrange interpolation and Newton divided difference. For Lagrange interpolation, our group take linear, quadratic and cubic approximation. For linear approximation, we only take on the last two data, which is 2016 and 2018. Sub the value into the formula and get the answer. Next, use last three data for quadratic approximation. There are 2015, 2016 and 2018. Sub the value into formula and get the answer. Lastly, for cubic approximation, we use four last data in 2014, 2015, 2016 and 2018. Sub the value into the formula and get the answer. Okay, for the second method is Newton divided difference. First step is putting information in the Newton divided difference in the table. Step 2, we calculate first Newton divided difference using formula and get the answer. Step 3, calculate second Newton divided difference using formula and get the answer. Step 4, calculate third Newton divided difference using a formula and get the answer. Step 5, putting all the result of Newton divided difference into the table in step 1. Step 6, construct the Newton interpolatory divided difference polynomial using this equation and sub the value, and we got the data of petroleum liquid generation in 2017, which is 8,982.5 kilowatt hour. Okay, that's all for me. Thank you.
Okay, for the next part is about the coding that we need to observe. The exactness of the value using the method Newton divider difference. Okay, for the coding we use, for the software we use the Maple software as our reference. Okay, by having this command, we were able to put the data from the question before. And this is our F0, that is take it from here, and F1 will be here, and the F2 also will be the next data, and the last data is F3 at the end of the matrix number. The matrix number. Okay, for the X is 2017. This is X is the missing data that we need to find, that is 27. Okay, for the X0 is the starting year that we need to have, and X1 will be the next year, that is 2050, and the last year is 2016. Okay, from this data, from this information, we will be able to fulfill this instruction. Okay, for the F, that is the exact formula that used to find the missing data. Okay, F0 that we got from the above data plus F1 S minus X0 plus F2 a bracket or times with X0 S minus X0, also we times with the X minus X1, also we plus with the F3 X minus X0, also we times with the same thing, that is X minus X1 and also X minus X2, and the simulation give us the final answer, that is 17965/2. This is the answer for the missing data. Okay, that's all for the coding. Thank you.
Hello and have a good day, Doctor. So my name is Joshua Isaac Felix. My number matrix AE210044. So now I will present for the long range part simulation. So firstly, we already try to use the linear method. Firstly, we declare what year we want to know is 2017, and then we put the 2016 and 2018 and also the data, and we got 9337.5 is already same with the manual calculation. So next is the for the quadratic part is also same, but we plus the value is this 20 or 15 for the first one, and end up with same linear. After that we got the 8913.33333. So the same answer with the Newton Raphton is cubic. So for the cubic, we add another value is this 2014 to get the same answer with the Newton divider rule. I think that's all for long range simulation. That's all. Thank you.
Now I will present the discussion for our project. As previously said, the method that we used are Lagrange interpolation and Newton's divided difference under the topic of interpolation. So, interpolation is a procedure used to discover additional data points or a missing data within a range of discrete sets of data points, which in our case, we need to find the missing value of petroleum liquids generation in the year of 2017. So, by observing the results from both manual calculation and the Maple software proving, our group obtained the same final answer for the value of petroleum liquids generation in 2017, which is 8,982.5 kilowatt hour. This means that both methods can be used to solve a problem that require us to find a missing value as long as it has a discrete sets of data points. But in our case, for the Lagrange interpolation method, we try to use the linear, quadratic, and cubic approximation method to see which method produced the most accurate final answer. And we got that by using the cubic approximation method, we can get the most accurate value for our problem. So to compare both Lagrange interpolation and Newton's divided difference method, we found that it is much easier for us to use the Newton divided difference method. This is because the Lagrange interpolation method require us to consider which is the suitable approximation method to be used to find the most precise value. And it is proven that we can use the cubic approximation in the Lagrange interpolation method after we have done the calculation by using Newton's divided difference and prove it by running a simulation by using Maple software. So, to conclude, the best solution for our problem is by using the Newton's divided difference method to find the interpolated data for the year of 2017. To conclude, if an intermediate value of x that is not in the dataset exists, we may have the range of pair xy datasets and we need to estimate the value of y that corresponds to it. In order to do this, we require interpolation that offer methods to approximate the function f(x) at intermediate points of x within the range of the given discrete data collection. Tabulated data can be analyzed by using numerical methods, which is particularly interpolation methods like we use in our project. Additionally, the interpolation method is useful in the engineering profession to assist engineers in obtaining an approximation of a missing data. We also anticipate that the interpolation method will be useful for us in the future for a research involving a tabular data. In addition, we urge more investigation into the study of power usage to reduce energy waste from the incident that may be fixed. Since fossil fuels and coal will be eventually run out, energy should be used as fully and efficiently as possible. As electrical engineering students, we also aim to be among the engineers who contribute to the study of sustainable and renewable energy sources to replace the current technique of producing electricity by using fossil fuels and coal. That's all from our group. Thank you.